Okay, hi, it's Christopher. This is going to be the final lesson on kinematics. So this will be the fifth video, and we did go over all the kinematic equations you will be needing for this year's physics class. Um, I will name the titles of the videos parts 1 through 5. So you will have to watch through every video in order to understand or know what equations I use when and where. But I will try to put the easiest first, hardest last. But if you also need help, you should watch the videos. Hopefully this does help you. And for this fifth one, I wanted to do a kind of overview, or I'll give you one of the hardest problems and see if you can put it all together. So a van travels at a constant distance of 18 meters per second for 4.3 seconds. It begins to accelerate at a rate of 3.4 meters over second squared for 5.1 seconds, and then it maintains that speed for 15 seconds. Finally, it slows down to a rest in 14.8 seconds. How far did the van travel? So here it's just, it wants the total distance of this whole trip. So if you want to imagine a car driving, speeding up, slowing down, how much or how far did the car go from point A to point B? So that's where you will need to break it up. I'll try using different colors. So let's do red for the first part, and that would be a the constant speed of the car is 18 meters per second for 4.3 seconds. So here you would use the d equals vt. Again, this is what you would use simple equation for constants. So your velocity is going to be 18 meters per second times 4.3. Also, this is a really pretty color. I like this. But your total distance is going to be 77.4 meters. Keep that distance handy because we will need this. We will need to add it all up. So now for the second part, it does say it begins to accelerate at a rate of 3.4 for 5.1 seconds. And here we can change colors. Let's go to green. So we have to acknowledge what we do have, 3.4 meters over second squared for 5.1 seconds, and it is acceleration. In order to find the distance, we want to see what we have so far, or what equation we would use. But so far we have the final velocity, or no. Yes, we're looking for final velocity, or which would be how far we're going. So we have our initial velocity, we need acceleration, we need time, and we need final. So here these are given. The time is going to be 5.1 seconds, acceleration 3.4 meters over second squared, and our initial is going to be 18 meters per second because that is where we left off. Because yes, that is where we left off in the previous one. So if you do the quick math, not quick math, but or you do plug it into the equation, we forgot that part. We have to find the equation that has all these variables. So in order to find final velocity, it's VF, my bad. VF equals VO plus acceleration times time. Again, just plug it in, it'll be 18 meters over seconds plus acceleration, which is 3.4 meters over second squared. And multiply this by 5.1. And this should give us our final velocity, which at this point we would get let's see, let's do 3.4 times 5.1, 17.34 plus 18 equals 35.34. 35.34. So keep in mind this is our final velocity. No, excuse that. That is not our final velocity. That is another distance we're looking for. Um, these x's, these should all be x's. So this would be another distance you found for the acceleration. Sorry about that. I wasn't talking about velocity. It was distance. So with a total of 5.1 seconds with acceleration of 3.4, you'll get distance of 35.34. Okay, so now for then the second part, maintains, let's see, maintains the speed for another 15 seconds. Here you also want to do a different equation. Okay, so you want to use a different equation. And then for this, you want to do, or want to also take care of any variables you do know you're missing. So here, you would, again, it would be easier with the graph, but it's going to be harder for you to maintain all the information that you've been given. So you would use, here, let me write this down, d equals initial velocity times time plus 1.5 acceleration 3.4 time 5.1 squared. And then if you want to do the math, I do like to split it up into two. So I take these two parts, I get 98.1 or 0.8, and this would be a 1. So 91.8 plus 44.217 if I'm not mistaken, and you should get the total distance of 136 meters. Again, take care of this distance because you won't need it. Final distance we're looking for, it's going to be finally it slows down to a rest for 14.8 seconds. How far has it traveled? Again, this is going to be a final one. And when you to a rest to 14.8. So to whoever caught my mistake, you're pretty smart. So I had said before to change these into x's. Again, my bad. It is 3 a.m. Change them back to velocities because we only found final velocity. And with the final velocity, you're supposed to multiply that by the 15 seconds that were maintained. So you do the quick math of 35.34, it's just 5 times 15 seconds, and it just equals, let's do the math, 35.34 times 15, 530 plus 1 is your distance. So keep that distance. That's your new distance for green. Again, my bad, it is pretty late. So now for the part where it says slows down, and where the van slows down for a rest and 14.8 seconds. Again, let's write down our velocities. So here is where you need a graph, or where a graph can help, because this would be, you take your initial points based off your last point. So your new initial point would be considered your most current last point, or last velocity, which would be 35.34, because basically that is when you do come to a rest, and that's where the new speed would come in. And then you're looking for final velocity, or that is what you have, which is 0, because it slows down and it comes to a rest. And the time you're given is 14.8 seconds till it comes to a stop. Okay, and then with this, let's jump over here. So with these numbers, you can actually plug it into the simple equation of distance equals 1/2 initial velocity plus final velocity times time. Again, you plug them in, so you get 1/2 times 35.34 plus 0 times 14.8, and then you get the total distance of 261.5 meters. So now, this is where the actual answer comes in. The question is asking finally, how far did the van travel in total? So this is important, or this is why it's good that I kept track of all the colors, or switched colors. Okay, it's still a pretty color. So let's do this. I don't know what color this is. But now let's take all our distances that we traveled. Let's do the math here on this side. Should be 77.4 plus, what's the second one we found? 136 plus 530.1 plus 261.5, and then you get the total of, let's see, 100 or 1005 meters miles. Or you're given, I guess, unit for distance, so it's going to be the total distance that the van traveled throughout its whole trip. Hopefully I wasn't too all over the place for this, but I will let you guys, or give you guys time to write this all down, take it in. But let me erase this one part so I can show you guys what I was talking about earlier about graphs. For questions like this, it's important to know, or important to know what you're looking at. And I would use, when I was in your class, I would use graphs to draw the picture. So here, let's say, well, let's say you're the car, or you're in the van. Let's see, we used what color was it? We used red. So for the constant speed, it was 18 meters per second for 4.3 seconds. So that's going to be here. That's the car going right here. And that dot is where the 4.3 ends. Because then it begins to accelerate at 3.4 seconds for 5.1 seconds. Or 3.4 meters per second squared for 5.1 seconds. So it's accelerating from this point on. It accelerates, accelerates, accelerates for 5.1 seconds. And then it maintains that speed for 15 seconds. So it maintains that speed. And that's where I messed up the velocity for distance. So just make sure you go ahead and you multiply 35.34 by 15 because that is the constant time for how long it's spent. And then finally it slows down in 14.8 seconds, which we did in blue. And it slows down and comes to a stop. Let's see. So that So these are the total distances you're looking for, and this is what we added all together, in case you're wondering. So 1, 2, 3, 4 distances we have from the side, and you have 1, 2, 3, 4 plot lines or 4 types of equations, if you did write equations, for your problem. So this is kind of a bigger problem where we put everything together, but it's easy to know because you do know have all the equations, you know how to use them. It's just a matter of breaking the equation or breaking down your problem efficiently, and so you don't really stress yourself out. Because in tests, when you stress yourself out with questions like these, is when you waste the most time. So you want to be as efficient as possible. Hopefully this helps you. If this was too slow for you, try watching this at like 1.25 speed on YouTube. But hope you enjoyed. Enjoy.